Hello guys, welcome to our YouTube channel Chemistry with Coffee. In today's talk, I will be focusing on the principle and experiment of column chromatography. Let us dive in. Assume that you did an organic reaction in the lab and wanted to purify the product. Do you know how can you do that? It's possible by using column chromatography. Here we have the TLC of your reaction from the previous thin layer chromatography talk. If you haven't watched that video, please go back and watch it, because the principle and experiment of both the TLC and column chromatography are the same. Let's see the purpose. The purpose of column chromatography is to separate different compounds present in a sample mixture. But the question here is how it can be separated. Let's see the principle first. According to partition chromatography theory developed by Martin and Sinjay, mixture of compounds will be separated between two liquid phases, similar to the liquid-liquid extraction using separatory funnel. Partition coefficient or distribution coefficient, that is Kd, is the concentration of a compound in phase 1 divided by the concentration of compound in phase 2, where both the phases 1 and 2 are immiscible. Coming into the column chromatography, Kd becomes concentration of compound in stationary phase divided by concentration of compound in a mobile phase. Stationary phase can be silica gel or alumina, etc. Likewise, mobile phase can be solvents like hexane, ethyl acetate. Some compounds have high affinity for silica gel than the eluting solvent, so the compound spends more time with the silica gel and move down the column very slowly, and it takes longer to elute into the receiver below. Other compounds might have high affinity for the solvent, so the compound spends more time in the solvent than the silica gel and move down the column faster. For example, a morning jogger has more affinity for the road than a car. She takes longer to reach the 5-kilometer stretch. And a guy going to the office has more affinity for the car than the road. He takes less time to reach the same 5-kilometer road stretch. What I wanted to say is that affinities vary among compounds. Here we have the structure of silica gel. It is very polar substrate with so many hydroxy or OH groups present. The experiment can be broken down into 4 parts. First, experimental setup, column packing, elution, isolation of compounds present in the mixture. First, look at the experimental setup. Take a clean and dry column, fix it to a stand and put a small piece of cotton at the bottom of it if the column is a fritless column. Otherwise, if the column is a frit column, like here, just leave it as it is. Second one, column packing. In here we have 2 methods. First one is dry packing method and second one is wet packing method. In dry packing method, silica gel powder is directly placed into the column from the top opening, followed by the solvent. Some amount of solvent is absorbed by the silica gel to form a nice bed of column, and the remaining solvent will be drained into the receiver present below. While in wet packing method, first we make a nice slurry of silica gel by combining with solvent. This slurry is then added carefully into the column from the top end. Allow some time to drain the excess solvent, leaving a nice and solid silica gel bed inside the glass column. After preparing the silica gel bed, place small amount of the sample mixture, either it is liquid or solid, on the top of the silica gel bed, followed by a layer of sand. Third one, elution. Elution is extracting a compound from its mixture by the use of solvent. Few things to remember before we start. First, make sure that silica gel bed is not dried out during the experiment. If the column is dried, it cracks and becomes useless for the experiment. For that, always keep enough solvent in the solvent reservoir on the top of the column. Start the elution with nonpolar solvent first. As the solvent is moving through the mixture in the column, it dissolves only the nonpolar compound as it has high affinity for this solvent. So the compound A moves along the solvent faster than the other compounds and elutes first. It will be collected in the receiver below. As soon as we have this, check its TLC by taking reaction mixture as reference, as shown here. As most of the organic compounds are colorless, unless we check the TLCs of the receivers, we will not know what's in there. Continue adding nonpolar solvent. If the receiver is full, then replace it with a new one and label them properly. As we can see from the TLC here, that first receiver has just solvent also in the second and third receivers. Even we haven't eluted anything so far, don't increase the eluting solvent polarity suddenly. After checking TLC of the fourth receiver with the reaction mixture, we see reactant A is present in it. Same way we check the fifth receiver TLC, it has just solvent. It means that all the compound A is eluted into the fourth one. As we have eluted all compound A, now we can slightly increase the polarity of eluting solvent to 5% ethyl acetate to push the medium polar product out into the receiver. As we can see, the sixth receiver has our product as confirmed by TLC. Continue adding same eluting solvent and check the receiver number 7th TLC. As we can see on TLC number 7th receiver has just solvent. So far we have successfully eluted compound A and product into the previous receivers. And now only highly polar compound B is in the column, which is moving very slowly as it has high affinity for the silica gel. We can now increase the polarity of the solvent to 10% ethyl acetate. As the more polar solvent is moving down the column, it can now dissolve and transport B compound into the receiver number 8th. This happens because our B will now interact with the more polar eluting solvent. Continue collecting next fraction number 9th to make sure all the B has been isolated into the previous receiver. What happens during elution is, as we use more polar solvent for the elution of polar compound B, initially B has high affinity for silica gel, but now B will have high affinity for polar solvent and moves faster through the silica gel column along with solvent towards the bottom into the receiver. Or we can say initially polar B is strongly adsorbed onto the silica gel. After using polar solvent, this polar solvent replaces the polar B from the silica gel. Now B has been freed and will be eluted faster, and some solvent molecules will now occupy the previous B positions on the silica gel. Finally, we can now conclude the following points from the TLC of reaction mixture and all the 8 receivers. First, only solvent is present in the first, second, third, fifth and 7th fractions. Reactant A is present in the 4th receiver, product is in the 6th receiver, reactant B was hiding in the 8th one. To get the compounds from the eluted solutions, distill off the solvent from the receiver beakers to extract the compounds. Likewise, we can isolate all the 3 compounds present in the mixture. For example, to isolate the product, place the solution of 6th receiver into a clean and dry round bottom flask. Then follow simple distillation procedure to remove the solvent of the solution. After distillation, product will be left in the round bottom flask. Scrape and carefully scoop out the product inside the round bottom flask. Then store the product in a clean and dry glass container and then label it properly. Okay, that's it for today guys. Thank you very much for watching and stay tuned for the upcoming video on simple and fractional distillation. Please like and subscribe our channel Chemistry with Coffee.